Pero bueno. So the money disappearing.
I have to rebook my flight because they put a meeting in Santa Clara on Friday that I have to be there with the head of site, the new head of site. So,
Okay.
do you have something tonight? If you have time, we can have dinner or something quickly. Or
Yeah, we can go have a quick dinner. There's a side meeting I was going to go to. I'm just looking it up. Hold on, this calendar.
Sabah no. Now you're telling me Sabah you just woke up.
So, yeah, right now I can't see anything.
But after the plenary?
Yeah, I don't know if that meeting starts at 8, which isn't much time. Or if it starts at
No,
9.
you said here.
But we can go for a quick.
No. Okay.
Oui, ça va?
Oui, c'est bien ça.
Salut. Qu'est-ce que j'ai vu? C'était adopté par Intarea. C'est pas expiré. Et j'ai vu autre chose sur la liste. Et c'est pas dans l'agenda. Je leur demandais si c'était prévu.
C'était adopté.
C'était adopté.
Mais est-ce qu'il expirait?
Il expire dans 2 documents.
On a un update de tout ce qui se passe dans la liste, mais...
You're late. Am I? I cancelled.
You have everything you need? Yeah?
I think we do, yes.
Ah ouais, mais là, avec cette chaîne. J'ai demandé si on avait des nouvelles de GUE. Parce que le draft s'expire après-demain. Et il n'est pas, c'est pas dans les agenda. Tu sais que les drafts c'est le draft
Generic.
plus qu'il y a le nom d'auteur. Mais il est adopté. Ouais, mais il est adopté. Enfin, il est. L'auteur, il en parlait.
Ah ouais.
Alors,
c'est le draft dedans. Non, il n'est pas dans. Enfin, oui, à bon. Non, il n'est pas dans.
si, il est là.
Il est là. Les deux plus attendent, mais ensuite, comme est-ce qu'il est dans la liste, c'est revenu du tout depuis.
Ok, bah, mais il va présenter.
Non, il présente Isle. C'est pas dans l'agenda.
Non, il va présenter une autre chose, mais on peut lui poser la question.
On peut l'embêter. Si je vais présenter un truc, il va t'interroger, c'est pas grave. Bon, c'est que dans le monde, j'ai pas retenu. Ah oui.
Merci.
I'll double check. Yeah. I just didn't get an echo. Thank you. Please let me know. All slides should be available already.
It's time now.
No.
Hi everyone, welcome to Intarea at IETF 100. Sorry we're a few minutes late.
So Note Well, everyone should be familiar now with the Note Well. Yeah. Sorry, would you guys mind taking your conversation outside the room? Thank you. So everybody should be familiar with the Note Well. If not, please do read it. This is an IETF meeting in Intarea. As you know, minutes are taken. Thanks so much to Ian for that. The meeting is being recorded and your presence is logged. Blue sheets are passing around. The online minutes will be on this Etherpad link if you want to take a look and contribute during the meeting. The recordings and minutes are public and may be subject to discovery in the event of litigation. So please make sure you sign the blue sheets also. They are going around. We have a note taker. Can we have a Jabber scribe? Someone could help us with the Jabber, please?
Okay.
Thank you very much. Thanks a lot, Michael. Ian. Great. Okay, and thanks, Ian, for the minutes. So the agenda, we're gonna give you a quick update. Then we're gonna have updates from the TSV, from Gory. Is Gory in the room? Okay, great. Perfect. So then we have the provisioning domains from Eric, Tal, Tom, and Vladimir, and Jinwei at the end. We have a couple of remote presenters, so we're going to try to make it as smooth as possible. Moving on to the working group status update. The privacy considerations for IP broadcast and multicast, well, it's been submitted for IESG for publication, so that's good news. Generic UDP encapsulation, there's an update to 0.4. IP over intentionally partially partitioned links. The current version is expired, and I don't know if Eric, do you have any comments about the IPPL? It's just the current version is expired, and if you can give a quick.
Eric Nordmark. Yeah, I know, and I have some edits to do based on some comments from Pascal, so I need to go do that. So, but I don't have anything else on the list. So.
Okay, thank you. Then the probe document has also been submitted to IESG for publication. And IP tunnels in the internet architecture, well, we're still waiting for updates to incorporate the BCP recommendations. So hopefully Joe and guys will take care of that. Perfect. So next on the agenda is Gory. Oh, yeah.
Hi, I'm Gory Fairhurst from TSBWG. I will try and take you through 4 drafts. This is interesting. I'm going to try and move further back so I can read with my bifocals the thing on the screen in front of me. That's better. Okay, so I'm just going to look at 3 drafts in TSBWG and quickly highlight them because they may be of interest to you or they may be of interest to things that you're going to develop in the future. Next slide. First one is work that's practically finished, but not quite. We've been, for some time, supporting DiffServe in various ways, and there is work to produce a lower effort class for DiffServe and specify it so that we can have scavenger class traffic, things like software update, background download, wherever you want that's less service than is offered by best effort. Some people are running this in the network with CS1, which was a DiffServe code point used for other purposes. Doesn't really fit into the DiffServe framework, so a TSVWG work item by Roland, who's over there, is trying to set a new standard DSCP. And our primary goal is to avoid other traffic being mistakenly classified as scavenger traffic. And to do that, we're going to open a new registry, if we can, which is we're going to start using the DiffServ code point pool 3. Whether we do that or not is a thing to be debated on Friday. So if you understand DiffServ and you're interested in the use of DiffServ code points in your networks, then please pay attention to that last line there that we're going to talk about this on Friday. Okay, probably good enough. ECN's probably a bit more something that people have been talking about recently. We have a draft called ECN Experimentation, which is about to be finally published as an RFC. So this is heads up of work that's being done, but it has implications for many people. The changes it makes are, first of all, it changes the use of ECT1. The ECT1 code point in all IPv6 and v4 packets now is repurposed. It specifically is being allocated for use for experimentation. And the important thing is that equipment must not now interpret a CE mark in the ECN field to mean that a packet is loss equivalent. It doesn't indicate a packet has been lost. It indicates only that the packet is being congestion marked. That may make difference if you're monitoring networks or if you're using that information. It also makes difference to the transport protocols. So the transport protocols are being updated. Separate updates are in progress in TCPM to do an update for the marking when ECT 0 is set, the first ECN code point. That's the ABE work. That also is very near working group last call, so look at TCPM for that. And the work on ECN++ and a family of drafts referring to L4S, which are progressing through the TSVWG group. All of this is transport stuff, but if you're interested in network layer headers, the bits are carried at the network layer, and people look at them at the network layer. So there's an interaction here, and that interaction has changed. Next slide, please. Final one, and I guess one of the reasons why I was asked to come and talk here by my co-chair was we're considering work currently on adding path layer MTU discovery for datagram protocols. So let me just talk a little bit slowly through this one. We all know that TCP can send big segments through the network, and that even works when you're using PPOE or any other encapsulation, because magically TCP figures out how big a packet to send. How it does that varies. Sometimes it takes path to big messages, and that's good when that works. Sometimes it uses MSS clamping. That's common in DSL networks. They simply rewrite the field, and eventually endpoints learn the right way. And many TCP stacks also use path layer MTU discovery, which sends big packets through and checks using the transport protocol whether those packets get through, and therefore has a firm understanding of what actually works. Of course, all these three things are usually used in combination, and I don't know anyone who's actually looked at which ones are the most important, because we tend to do all three of them, and hopefully between them we get a good answer, because TCP kind of works. Oh, but oh dear. Some people don't think we're going to use TCP much anymore. And there are tunnels and other things out there that don't use TCP, surprisingly. So what happens when you don't use TCP? Well, of course, the ICMP path to big messages still give you advice of sending a too big a packet, so that part of the algorithm works. But it's not universally supported in the network. Many path to big messages get filtered, black holes occur. So wouldn't it be nice if you could do a similar sort of treatment for UDP packets? And that brings a whole load of issues. Like, how do you choose probe sizes? What sort of data do you probe with? How do you react when you lose a probe? Some of these paths are unidirectional, so we have to provide some sort of feedback mechanism to make this happen, and you may even have to probe to see whether the data is getting through. It's all a little bit of a tricky mess, but we were brave and we proposed something. So next slide. Going to talk about this on Friday in TSVWG. What we're proposing is a state machine which tries to find a good, effective path MTU for a UDP or a protocol running on top of UDP. The ones that we're actually targeting at the moment are the SCTP-based encapsulations, because we have running code in BSD that actually does most of this. We can adapt that and bring that up to date to make it work. We have work with UDP options, which is Joe Touch's draft in TSVWG, to stick a few bytes between the UDP payload and the IP header. Some people think that's gloriously good. Other people think it's horrible, but it is a way of transporting the information you need for this particular piece of work. If the work is adopted, then we'd like to pan it out to look at other transports, and that could also include tunnels and anything else, perhaps even wonderful quick if they want this way of doing it. Currently an individual draft, and is to be discussed on Friday at TSVWG. Maybe we won't adopt this time, I don't know, but I think in future we'd like to do some work in this space. That was my very quick overview. I'll happily answer questions if there are any.
Thanks a lot. So are there any questions now, more from the Intarea perspective? The discussion, as Gori said, is going to take this particular last item on Friday at TSVG. But are there any quick questions now? Okay. If there are none, please, if you're interested in the topic, please do participate on Friday at the working group session.
Yep, heads up, it's going on. Thank you.
Thank you.
Eric?
Okay, here's an update on the PVD draft. It's the first time we are presenting the -00 since it has been accepted as a working group item around September last time. So that's a draft for a couple of people. All the authors are in this room as far as I know, so maybe except David and Marcus. So what are PVDs? There is an RFC that explains it, and basically I will spend 2-3 minutes explaining what the PVD is, and then we'll jump to some more discussion and updates. So PVD is a set of related information. Think about DNS name servers, PIO, next hop, and so on, that works together. And PVDs can be identified by what you call the PVD ID, both on the network transmission as well inside the host. We also think that we can go much deeper or much further than plain DNS information. We can provide information, for instance, about whether there is a captive portal, whether there is a walled garden, and to which set of IP address the walled garden is limited to. We can provide maybe on some bandwidth measurement or settings for the first hop. The current proposal is to use into IPv6 router advertisement only. So that's mainly targeting IPv6. We can work maybe as well with IPv4 if we want to do it. I will describe mainly the v6 part. So in the array, we use a neighbor discovery option. Let's start, of course, with the time, the length. We have a couple of bits that are reserved, and 2 of them are important. We have a sequence number. I shall come back on this. And we have the PVD ID. The PVD ID itself is a DNS, fully qualified domain name. That's very important because it allows you to fetch additional information. 2 things to note here. It's very simple. It requires as well, if you have multiple PVDs inside the same network, it needs to be sent in different arrays. So it's 1 array per PVD. That's the current set. And Ted, I will come back on your comments on this. 2 flags. H signals that you can use the fully qualified domain name that's there to fetch more information from a server over HTTPS. The L bit says, hey, you can associate this PVD with the information you receive by DHCP v4. Obviously, you can have one and only one PVD with this bit set, right? Sequence number are for what? Simply because we use, if you have the H flag, we use the fully qualified domain name to fetch additional information. Once and then you forget about it. As soon as the sequence number is changing, the host is required, or should at least, to fetch a refresh. So if you change the additional information, let's say in 1 hour, then you push an array, multicast or unicast, with a different sequence number, then all the hosts will simply trigger a refresh. That's a way to push new information here. So, as I said, if you have an array, a PVD, one PVD per array. Legacy router sending arrays without the PVD ID options are becoming what we call an implicit PVD, which are identified by locally on the host by the interface and the link local address of the router sending this array. That's a unique ID. We can use as well and link the information that we can receive by DHCP v6 simply by assuming that the DHCP v6 relay or server has the same link local address as your router. It's not perfect, but works most of the time. So more information. As soon as you have the H bit set, what you do, and it's a should, it's not a must, by the way, the host can use HTTP over TLS and fetch this well-known URI and the PVD. This basically information retrieved over HTTPS is a JSON file. Some example here. We require to put a name. We require to put an expiry as well. And so when this one expires, you need to fetch a new one. It's kind of redundant on the sequence number, but it's a kind of more foolproof. And we have the set of prefixes that basically say this PVD applies to all those addresses. So kind of to make sure that there's no misconfiguration there. Then you can add the properties, like for instance, I put here a characteristic for the first hop, so something, let's say, between your VDSL router and the DSLAM, indicating the maximum throughput that you can achieve, and so on. Other examples below are more about whether there is a captive portal, walled garden, and so on and so on. Pretty flexible here. The host behavior is basically, if you support the PVD, you can ask an application or everyone to basically use one PVD or another or a set of them. Now, with the current status, if you receive 3 PVDs and you are non-PVD aware host, you will process those 3 arrays and you will basically mix all the information together, leading to the classical issue that we have right now. So PVD does not solve this problem, doesn't make it worse. Jan.
Ian Farrow, Deutsche Telekom. So yeah, I've read the draft, and first of all, thanks for picking this one up. It's been kicking around a long time, and I'm glad that someone's having another go at it. The case that you've got there of it being no worse than things at the moment, that one's a problem to me. I can't solve this at the moment, and here comes another solution that actually doesn't work in this case. I think it would be really good if we could discuss, possible ways. We've been talking at some length earlier today with some of the authors. There may be some ideas kicking around, but I think it would be really good if we could bring this into the scope.
Yeah. And thanks in advance for your help on this one. We have at least among the authors, at least 2 solutions on this.
Oh, okay.
Yeah.
That was quick.
Yeah, could be cool.
I look forward to it. Thanks.
Ted Lemon, just to amplify slightly on what Ian just said, the situation with this configuration is different than the situation that you would experience in a network that was just advertising without PVD support at all. It would just send you one RA with all 3 prefixes. And so the behavior of the host could be expected to be different in that case, and that's really the concern that I have, and I think possibly that Ian has. So I'd really like to see a solution that allows us to basically make the PVD options invisible to a host that doesn't support PVD, so the host doesn't see a change in behavior on the router, and only PVD supporting hosts see something new.
Okay, fair enough.
Lorenzo Coliti, I'm not a fan of the idea of having implicit PVDs be specific to the link local address, because it would break use cases that exist today. One use case that was used in the IETF network a couple of meetings ago was you had one router doing RAs and with PIOs, and one router doing RDNSS, because the main router didn't support RDNSS at the time. And the behavior in all existing hosts, was to take those two and put them in the same PVD and use them consistently. And if you have a new PVD-aware host and you put them in two different PVDs, you've got two implicit PVDs that have broken configuration, and suddenly you have an implementation problem, so you have to decide what to do. And so basically your new host on an unmodified network behaves differently.
Okay, do you have any suggestions on this?
Yeah, don't put them all in the same PVD.
Even if they're coming from different routers with conflicting set of information?
If they're conflicting, that's a configuration error today, and it's still a configuration error tomorrow, right? So if you put in conflicting information today, then it doesn't work, and it still won't work tomorrow, probably.
Yeah.
So.
Tommy Pauly, Apple. So as a co-author, one thing to respond to Lorenzo, I think that's a good point. I think as part of this, if you say that if we want them to be distinct, then just add your PVD name, make it explicit. You can do that all the time. And then if you want to join them explicitly, you can put the same name in them, and that's great. So I think we could probably weaken the implicit one to say that, this can work if you have one implicit PVD that gets the other options. It may be full of dragons if you don't know what you're doing explicitly. So be aware that it has the same problems it has today, but essentially we're giving you a name for the PVD ID to rationalize it if you so see fit. And then to Ted's point, definitely I think this is something that needs to be addressed, and I think that's the main weak point here. There have been two general ways of solving this problem that we've discussed. One, which I think has come up more in the past, but I think we don't like as much, is going the approach of having kind of containerized PVD options, in which I imagine still the legacy v4 PVD would probably still want to be a name, and all the other RA bits would be exposed on the outside, but then you could have other RAs essentially just be PVD containers. That can work. If we need to go that route, we can. There's a little bit more ugliness there, because then we're kind of stuck long-term with a solution which some things are containerized, some are not, and it's essentially a long-term compromise for a short-term problem while we're dealing with devices that don't know about this. One other option that Eric Klein and I and Lorenzo were discussing earlier was if we can essentially change how, on one hand, when a router solicitation is sent out, if we express in a bit that we are PVD aware as a client, we could receive unicast RAs for the extended PVDs that would not go out to other clients. And then on the advertisement side, we could essentially define that there is another multicast address that is the other RAs are sent out to all the time, and that PVD aware clients will listen to both and accept RAs from both and treat them completely equally, and they don't really care where they come from. But then anyone who is not PVD aware would only be looking at the traditional multicast address, and they would only see the same view that they would see today. And so it means that you have a lot of flexibility, but then you also can end up having a relatively sane and simple deployment when you know you don't have legacy clients in the future.
Ted Lemon again. So the way that we contemplated solving this problem back when there was a MIF working group was that we would just have PVD options in the RA, in the prefix. There would be sub-options of the prefix option, and those options could in turn contain sub-options that had information about which name servers to contact if you were going to use the PVD. And so you would just put the name server that you want non-PVD aware hosts to use in the outer prefix or in the outer RA, and then you would put the specific ones inside of the PVD option. The only reason I can think of why that's bad is if there's just not enough room in the RA for all of this information. But are we that space constrained in the RA?
Yeah, this is basically, yeah, of course, because array cannot be fragmented. So that's already an issue. That's one issue we see with this, which is what we call the the PVD container. That's, I think, roughly the same thing, the same concept. It's basically making PVD unaware people ignore this set of information. So there is one issue, the size. You can be limited in the amount of information or the amount of PVD you put there. And pretty much like Tommy said, we are basically making a solution ugly for a short term. I mean, solution is on the table, right? So to be discussed.
Ted, to respond to your earlier comment, I think one of the main things that are an improvement, I think, one of the main things that we've improved over the thinking that we had in the MIF timeframe was that the HTTP over TLS doesn't have any length limits, and it can be like much more easily extended, right? And I think the container option suffered not only from these length limits, but also like essentially duplication of information. And yeah, that even like the two multicast group solution isn't really super elegant, but it does eventually go away, right? It can eventually go away.
Hi, Bob Hinden. Two comments. I mean, I think I made comments on this draft at the mic in the last Intarea meeting, and I sent comments during the adoption call. So I still object to the use of putting URLs in here to load this stuff. I think it has very poor fate sharing properties, because it's going way out of just the internet layer up to, to the application layer. And I'm not convinced that you really need to have that much data that you can't put in, datagrams. And the other issue is I raised my comments during the adoption call is there's Appendix B with a bunch of stuff about billing. There's nothing in the rest of the document that uses the word billing, and I think it should be removed. I don't think we should be doing a billing protocol without talking about it. And it seems like this is just, I don't understand why it's there at all. So I'm surprised to see it in the new draft.
Okay, to be honest on this one, there's a mistake of mine. Forget to remove it.
So you will take it out?
I will take it away. That's no problem. Again, mistake of mine. Now, when we disagree, I think we need to agree that we disagree on the fetching of HTTPS and some of the application layer, because that's really important to store a lot of information there that you cannot put in the single array.
Yeah, well, I think it's a bad idea. I think this will be very fragile, and it's going to have all kinds of odd behavior. I mean, this is information in a router advertisement, or an ND, and it seems then having to go and get stuff from the web is like, it makes my head hurt. So I think you should really think hard about finding another way of doing it.
Okay, maybe it's not nice, but it's efficient.
No, I think it isn't actually.
Lorenzo Colletti, to that point, we thought about this at some length, and we thought about many options. And one thing that was very clear in the mind of the implementers of this, and this has been true for months, years, and since these ideas have been kicking around, is that the initial configuration in the array must be atomic and must be sufficient to give you everything that you need to do networking, right? This stuff is a completely disjoint set of config information, which is upper layer config information. And it is at best metadata about networking, if not like entirely separate config information. It will never be a goal, and maybe we should just write this in very big block letters, in that it will never be a goal that you are not provisioned until you do this. You must have full connectivity. Well, you know, things like captive portal accepted that aren't under your control, but you must have full connectivity atomically upon receiving this RA, right? You have to have network layer connectivity. And this is, the rest, this is all metadata, right? Which you might not even ever want to care about fetching. So, and so I think we do understand your concerns, but we felt that, you know, if we had this hard separation between the two, it did make sense to use these other mechanisms. Other than the fact that we already do HTTP for provisioning, in the sense that the captive portal check is already HTTP, but like, you know, but there is even conceptually a solid, I think, distinction between the two.
Yeah. On the same topic, I was about to say about the same thing. The idea is that everything that is going to influence the networking stack of a host is going to be in the array. We are not going to put anything in the additional information that is going to modify the IP stack, the way the host behaves on the IP layer. The additional information is really intended for applications behavior, the way application work, the way applications decide on which PVD to use, this kind of stuff.
And by the way, Pierre Fitzer, what you said is pretty true. We have an implementation running on Linux. Everything which is related inside the array is within the kernel. Everything which is into the additional JSON files is into the user space.
So does the use model that was just talked about, is this well described in the draft?
It should be.
The clarification that Lorenzo just did, pretty much like Pierre, is not in the draft yet. That is in the mind of the authors. But
okay, well, you can then understand my confusion.
Absolutely.
Eric Nordmark, just to clarify that a bit more. So if this URL that you get is not reachable, the host will continue to operate as if it had never received a PVD.
Of course, of course, of course.
But,
So as I was discussing with Eric just now, Tommy Pauly, the presence of the PVD alone is a key piece of information. So the fact, yes, it helps you bucketize it. Like, it is still important information that is stored in the system at the interface management level. And yes, and it helps merge information across things. If you're not able to fetch this information, you should not behave any differently than you would had, right. So like, yeah, so it should be perfectly acceptable for that fetch to fail. That is intended for information like captive portals, which is truly application layer information. Because the other option is that stuff like captive portals, in order to get away from terrible redirections and stuff like that, ends up putting much more into the DHCP and RA space, because as we want to extend that or extend the capabilities there, we're going to start stuffing more into the IP layer. And we don't believe that's appropriate to be there. We believe it's more appropriate to kind of stuff on to some PVD extra information so we can get it away from the precious space in our DHCP and RAs.
Simultaneously an ID and a place where you can get to find, you go to find more information about that ID.
So yes, some additional text in the drafts would be useful. I have another area where I think additional text is required. So HTTPS, it's not clear exactly what this provides you other than confidentiality, basically the equivalent of anonymous diffie-Hellman. And it talks about doing some additional checks, but I don't know whether the entity on the host that's retrieving this stuff has a list of root CAs that it's going to validate against or not. Whether just a self-signed cert is sufficient, I can't tell from the text that's in there. So it needs to be flushed out. But the higher debate is, what problem is it solving? Is it just sort of confidentiality of this thing, or is it something else?
Okay, not taken for additional text regarding the authentication of the server. I mean, in our mind, it's a full authentication, pretty much like you do on the browser.
So you're going to have the list of 100 root CAs as
That's
part of
correct.
this? Okay.
That's correct. And
So
this
yeah,
is the same as the browser, right? So basically.
So yeah, that should be written down, yes.
Yeah, absolutely. Thank you.
Ted Lemon. So the reason I got up is because I was reading the slide and thinking to myself, wow, what's the trust model for all that information that you've got on that slide? It's not clear to me that you have a trust model, and that's something that needs to be addressed in this document. I don't know exactly what the trust model should be, but I tend to get a little paranoid about this stuff, like, you know, who can claim the name Fou Hotel à Paris Wi-Fi, you know?
I mean, pretty much like your SSID, right? You see SSID, which is...
Right, and that's a huge problem. Yeah.
And this one, yeah, you can claim whatever you want. But the point as well, it depends upon the user interface, which, if you have multiple PVD to select, will you show the fully qualified domain name that ends, for instance, like Verizon.com or Cisco.com or whatever. So, and you know it's being fetched over SSL, so you can trust somehow.
Right.
Okay. Or do you display the localized name there?
Well, this is exactly what I'm getting at.
Yes, I think it's
the
a
only
UI
thing that you
issue
can
there.
safely show that's been validated is the domain name. The localized name has not
That's
been
correct.
validated.
That's correct.
So that's not to say that the localized name can't in principle be validated, but if you want to put a localized name there, I'm arguing that you should figure out a way to validate it.
Tommy Polly Apple. I very much agree with your point here. The names, like certain attributes, like the captive portal API URL, is useful because it essentially is a way to communicate from the network that, you know, this is what it says you can do. If that doesn't pan out because that server isn't really there, well, then you know that there's something wrong. Yes, exactly right. So I do believe that most of the keys and stuff in here, I think from the key document, do need to be stripped out. I think, as we've been discussing, there probably should be some like IANA registry for how we register keys, and we leave it much more agnostic for now. Putting stuff in the UI, very problematic if that's not represented to the user what this really means or where it comes from. One use case for something like a name or identifier, we were discussing with Michael earlier about, you know, situations in which you say I have my generic internet PVD and I have a video streaming PVD. Some attribute like a name in there would allow not a user but an application, let's say, that's written for that network to say, you know, find me a PVD that claims it has this name. You know, it could be lying, but at least I will try it and, you know, do my own authentication with the actual end application server. And it is a hint for which one to use. So I believe use cases like that are a little bit safer or more useful. So we should look at that. It could just be an identifier too. Yeah, a cert name is fine, yeah.
Suresh Krishnan, like AD hat off. I think one of the things that could like kind of handle all of the questions raised is like a scoping statement, which says like, try to say like what the document doesn't address, like, because there's like a bunch of things that it doesn't address. And I think it's by design, right? Like, because if you add like this container stuff, like, you know, PVD aware, non-aware stuff, and you add the origin authentication for this thing, you end up with the same MIF draft, right? Like that we had. So I think if you have a clear scoping statement saying like, these are the known failure modes for this, or the things like non-goals for this document, I think that would set the tone for the rest of the document. So people don't expect to find something further down. And then like, you know, a working group can make the decision on whether that's the right set of things to do. But I think that clearly specifies like, you know, what's getting covered.
Thank you for the advice. Indeed. So come back on the document. So what we changed since the adoption by the working group, I rewrote the IANA consideration because we are asking for enable discovery option there. The PVD ID itself, which is a fully qualified domain name. At the very beginning, it was encoded internally as a DNS name, so kind of compressed, if you know what I mean. Then we make it plain ASCII. And then based on some comment from the working group, we move it back to a DNS format. Okay, so I think we are there. The DNS zones is mainly for the walled garden approach, has been added back. Based on multiple commands we receive, we rewrote the privacy section, and I shall come back on this. And rather than being informational, we are aiming at standard track.
Lorenzo Curi, why do we have DNS zones and and DNSSL? Like why? Like what am I supposed to do if I get both?
I mean, DNSSL is obviously for all your DNS requests. This one says in a walled garden approach, if you use this PVD, you will be reaching all the hosts ending by those zones, which is slightly different. Basically, we may want to change this. Okay, and of course there are inside and outside and blah, blah. But the point right now is to be able to specify, to scope the walled garden PVD. We could do it by addresses, maybe as well.
That sounds like it could get controversial. Okay.
Okay, we can talk about it. I mean, everything is open, right?
Ted Lemon, just to expand slightly on the controversy that might come up there, if you specify that a particular PVD supports a particular zone, doesn't that imply that that's the PVD to use for that zone?
Sure.
So that's a really great way to capture all the traffic for that zone.
I hope.
One other comment. The security considerations section has 2 sentences in it. I don't think that's adequate.
Of course, that's a revision 00, right? So we have plenty of time.
Yes. Well, I just went and looked at it.
But there are other security sentences in the text, by the way. So it's not. As I said, one big change compared to the previous one, at least for the existing implementation, is that we changed the way we write the fully qualified domain name, which is the PVD ID. WSASCII now it's following RFC 1035. We do it more complex, but it's okay. There was a huge amount of decision on privacy in Prague, so we tried to address it. One thing to note is that when we fetch the JSON file over HTTP, over TLS, it's typically this server will be within your administrative domain. It will not traverse the wild internet. And you will get anyway information by the host when the host is accessing your DNS server or is accessing your Radius server indirectly because it's authenticated, or your DHCP server if you're using DHCP, because you are within one administrative domain. So we make it clear in the text that it's typically within an administrative domain. And we all know that all operating systems, whether it's laptop-based or mobile-based, they try to discover whether there is open internet access or whether there is a captive portal. So they use a variation of the scheme which is described here. They go and open a connection to some well-known site and see whether what they receive is correct, yes or no. And then they detect whether there's a captive portal, yes or no. So what is the more private? Is it to go over SSL to one server which is within the administrative domain of the network operator, or going to a third party that you don't really know, including maybe the employer of Lorenzo?
Lorenzo Colidi. So I was able to read section 6 during the time you're talking about it, which I guess is a bad sign. But so what I didn't get out of section 6 was what's the threat model, in the sense that what is the privacy concern here? Is it this, let's say, user is running a version of an operating system that understands the specification? Is that the privacy concern here, or is there another concern? Like, what's the threat model? What is the privacy leak that? Because the document really doesn't say. If you have an answer, then you give it now. Otherwise, you should really put it in the draft.
Okay, which is, again, a fair comment. So it was, I think, Bob and Chris Utema that expressed the privacy concern. And what I get from them, and I think it's fair, is the fact that as soon the SSL server, which is there, will know that one IPv6 address is active. And that's it.
Well, it already knows that, right?
Exactly, that's my point.
So it's not hard for the network to know what is on the network, right? I mean, it go to dat probe. I mean, that. No, I'm pretty sure if Christian was here, he would be a more convincing. Do we have it in the minutes somewhere?
I mean, last time I talked with him, and I talked with him after the Prague meeting, it was exactly this threat. Now, you're right. We need to describe the threat against privacy in the draft, that's for sure, and see what this fits.
I seem to remember that what he said was more convincing. I can't remember it though, but okay. I guess we just need it there.
Yeah. And the last point, which is not on the slide, we advise to use one temporary address to fetch this SSL, and then do not use anymore this IPv6 address. That's an easy fix when you get privacy extension.
Would you mind speeding up now?
Yeah, easily, because that's implementation status. So nothing will change compared to Prague, except that at the hackathon we have opened the HTTP that also serving now array, and there is one router vendor, and you can guess the name, I guess, which is implemented this version of the PVD as into the array. Next step, so -01, of course, based already on the feedback we received today. We need to get, that's some applause coming out of the sky, find a solution and discuss with the group regarding this multiple array, what we do with the legacy host. And something I would really, really love, because we have multiple implementation running right now, and we are currently using the code, which is 253, which is experimental. And now again, somebody from the university in Japan came, can I get the code to run in my place? Okay, so we need, and I would love to get the consensus within the working group to get, through IANA, an ever discovery option for the PVD ID.
On this point, actually, going back to your previous slide where it says Linux implementation, has the kernel patch been sent for review upstream?
It's patched that are not upstream it yet.
Please send it upstream ASAP, because our lead time is measured in years. And do bear in mind, going back to the point that you have on the next slide, that the Linux kernel uses a version of, by default, uses a truncation of SHA-1 256 that is invalid. They implemented draft, whatever, and the RFC changed the final value, and we still can't fix it because of backwards compatibility. Upstream is rejecting patches to take the RFC value. So if this can, well, it's backwards compatibility. So I agree that it would be nice to have, if we end up having two values, one temporary and one final, I think it would be better to have a value that we can use for experimentation that is not going to change.
Yeah,
this is sooner rather than later is what I meant to say. Sorry.
Yeah. And when I say reclaimable for future, that's an easy way to get, while we are still a draft, to get a value, especially for neighbor discovery option. So that's within this RSC 4861.
Mark Townsley, I think I'm just going to echo a bit of what Lorenzo said. So it should be obvious that in order for us to upstream it, we need a real code. I don't think they'd take it with 253. And the section 13 of 4861 is perfect for our case, I think. So what we need is a consensus call from a working group that says, yep, you can have a code. And then Suresh can go off and ask IANA for that, and then it'll happen. And then, yes, we will move forward as fast as Linus Torvalds will allow us.
And if there is no more comment, I'm done.
Thank you. Suresh?
Yeah, so Suresh, so I kind of explained the procedure to Eric a little bit. So the request needs to come from the working group. So once they're ready to make the request, the chairs can do a consensus call and ship off a request to me, and I'll do it as fast as Mark can get Linus to also do something.
Thank you in advance.
Thank you. So next is Tal.
Okay. Just from the chairs, what's the plan for responding to getting a number and asking the working group?
Well, I think we're pretty late now, so how about taking it to the list?
To the list.
Well, you'll have to confirm it on the list anyway. But I sort of wonder, this seems to me like it's a long way from being done. And so, worry a little, doing the allocation too soon might create a whole nother set of problems, especially if there starts to be running code that gets deployed, and then are we going to need another one later? And so I'm not sure. Seems like a little fast to me.
Okay.
It's not like this just appeared. It's been going on for years. There's multiple hackathons. There's running code. There's multiple implementations. There are implementations popping up from people that we are not directly in contact with. All we're talking about here is a code. If we completely screw up, we can get another code. But I don't think that's going to happen. I'd like to hear from, maybe Lorenzo has an opinion on that. The process exists for a reason. We don't have to get full on RFC to get a code here. I'm not nearly as worried as you seem to be, and I've been deep in this for several years now.
Is there a process for clawing back the code? No, the RFC, I just read it. It says like when the option space is 85% full, we're going to look at all the reclaimable ones to see which ones are not in use anymore. And I can imagine how somebody with, how Bob's concerns like, well, that's, not going to happen in the next few decades maybe. So what do we have, are we going to have multiple implementations that don't talk to each other or have like incompatible packet formats or something, right? I think if there were a process to reclaim the code or to claw it back, then that would make it easier for us to actually devote a temporary code. Like if we can we have a code with an expiry date? I don't know.
But there is a process. You may not like it, but there is a process for reclaiming. Those are the IANA, considerations that were agreed upon.
Okay, then Suresh, and then I'm cutting the discussion, please.
Yeah, just explaining something, Suresh, again. So explaining about the early allocation. The early allocations expire. They do. Like it's not in that place over there, but like IESG keeps getting the early allocation like report every sometime, and I think it's a year or something where the expirations just go away. Like if it's just an early allocation which doesn't follow up, it just goes away.
Thanks. So Tal, please.
Okay, thanks. My name is Tal Mizrahi, and this draft is about packet timestamp formats. It's joint work with Joachim Fabini and Al Morton. Next, please. Oh, okay. Thanks. Okay, so the intended audience of this draft is network protocol designers. And the idea is that there are actually two purposes. One is the draft defines a set of recommended timestamp formats, a relatively small set of recommended timestamp formats, which should typically be enough for anyone who needs to integrate a timestamp into a packet, in most cases. For the specific cases where none of these recommended timestamp formats fit what you need in your new time protocol, your new network protocol, sorry, this draft specifies guidelines of how to define a new timestamp format. So the history of this draft, it was submitted a few months ago. It was originally submitted to the Internet Area Working Group. In the last IETF meeting, we presented it here and also in NTP. And based on the suggestion from our AD, it was finally submitted to the NTP Working Group. And it was recently adopted by the NTP Working Group. So it was still important for us to give an update here on how it's progressing. So we're going to talk a few words about the differences between the current version and the previous version, and also give a brief overview of what we have in the draft. So one thing the draft talks about in the new version, beyond the two main goals which I talked about 2 slides ago, is things you need to consider before you define a timestamp format or before you decide which timestamp format to use. So for example, if you need a timestamp, you'll need to think about things like the timestamp resolution, the wraparound period, the timestamp size, number of bits, and also coexistence with other protocols. For example, if you have NTP running on your system, probably makes sense to reuse the same timestamp format as in NTP. So in the draft, we defined 3 recommended timestamp formats. One is based on, 2 actually are based on NTP. One is a 64-bit format, another is a 32-bit format, and there's also a timestamp format which is based on PTP. So one of the things we do in the current draft is we specify some of the existing RFCs that use timestamps. For each of them, we show which of the recommended timestamp formats is used. In some cases, none of the recommended timestamp formats is used. And also, the draft includes a couple of examples of how you would use recommended timestamp format when you're defining a new network protocol. So it's kind of a cookbook for how to define a network protocol with a timestamp. Okay, so the next steps we're expecting, first of all, we've had a few comments on the mailing list, which we'll need to address in the next version. We plan to do that. Another aspect which we started working on and still needs to be expanded is creating a control field, an optional control field, which can be attached to the timestamp and describes information which is related to that timestamp. So that's something that currently we have a preliminary outline and we'll need to expand on that. After we do these things, we expect to ask for working group last call and the NTP working group. This would be a good time for any comments or questions. Okay, thank you.
Okay.
Yep.
Yes, this is Alexander Petrescu. It is the first time I see the slide set, and I also need to read the document. I wonder whether the discussion or the request from you for comments is open for comments related to adding timestamps from other protocols than the ones that you listed there that are relevant to networking.
Yeah, so we're open
Yes.
to any kind of comments.
Yeah, okay.
We'll be happy to hear.
Yeah.
And yeah, if there are more use cases that we haven't considered, we'll be happy to hear.
For example, the ones from localizations like Galileo or GPS, these are some timestamp, very important timestamp formats there. And the ones from IEEE like TSA, timestamp advertisements. These are 2 things that are very important to me. I don't know whether you want them listed here or...
Okay, so it would be great if you could read the draft and send these comments
Awesome.
on the mailing list. That would be helpful.
Okay, good. Thank you.
Thanks.
Thanks. Next. So next, I think we have remote, right? So Tom, are you? Oh, he was there before. All right. I thought I saw his name before. Yeah. So Tom, if you, yeah, he just made it back. If you can request presenter. He has to. Shall we go to plan? Tom? Or Vladimir, otherwise, you're next. Whoever requests the line will get it.
Okay, I'll take it.
Okay, great. Thanks.
No problem. So, hi guys, I'm going to give you an update on our latest work on SOX version 6. So, next slide, please. So, I'm going to give you a quick refresher on what SOX 6 does as compared to version 5. The main thing that we do is we shave off RTTs. So the client is very optimistic and sends as much information up front as possible. I mean, it advertises its supported authentication methods. it requests that the proxy open a socket, open a connection to a certain server, and it also sends some data. And it also tries to authenticate itself if it had previously communicated with the proxy. It's also extensible with TCP-like options in TLV format. And it also has support for TFO. So next slide, please. All right, so here you can see how SOX 6 compares to V5. So in V5, the client first says what authentication method it supports, and then the authentication process proceeds, and then it makes a request, and only after it gets a reply back can it send some data. In SOX V6, it sends a request that contains the authentication methods, what server to connect to, and also some initial data. Afterwards, the authentication process proceeds, and then it gets an operation reply back. Next slide, please.
I think it's taking a while for you to update, but the slide is on already.
Okay. And on subsequent requests, it can do zero RTT authentication, so that the RTT overhead is basically zero. So next slide. Let me just switch to the next slide. So the focus of the latest revision of the draft has been on security. We've chiefly concerned ourselves with protection against replay attacks. But first up, SOX version 5 lets you do encryption within the protocol. We've decided to deprecate that and just run SOX over TLS. That is the encryption de facto standard in use today. And we should request a new port from IANA for that. The funny thing about this is that SOX stands for socket secure. And then when we're going to run SOX over TLS, maybe it's going to be called socket secure. I don't know. Anyway, so TLS 1.3 has support for early data. It has no overhead in terms of RTT. However, this early data is prone to replay attacks. And since it's likely to contain a full SOX request and you don't really need to wait for a reply from the server in order to send some data. So SOX over TLS is now prone to replay attacks. So we kind of need a mechanism that can ensure idempotence for requests. And in order to do that, yeah, next slide, please. So in order to do that, we're going to leverage the SOX options. So this is for authenticated clients only. So authenticated clients can request tokens that they can then spend on SOX requests. A token can only be spent on one request. So if the proxy sees two requests that try to spend the same token, the second one is going to get discarded. So next slide, please. So this is basically how it works. So first the client sends a request, it gets an authentication reply back, and then an operation reply. Next slide. So the client is gonna include a token request as part of a normal SOX request. It doesn't really have to open a socket anywhere. It can just use a no-op and send a token request as part of the no-op. Then it gets a window advertisement back, which basically tells it which tokens are usable. So next slide. So the token request is pretty straightforward. The client basically asks for a number of tokens, which the server may or may not grant. Next slide, please. And the token window advertisement contains two fields, a window base and a window size. So the window base is basically the first token, and the window size is the number of tokens in the window. So if we've got a base of 10 and a size of 5, that means that tokens 10 through 14 are usable. So next slide, please. So afterwards, the client is free to spend those tokens on SOX requests. So it includes token expenditure options as part of its requests, and it gets an expenditure reply as part of the operation reply. And optionally, the server may include an unsolicited window advertisement. So next slide, please. So the token expenditure option is really straightforward. It contains only one field, which is the token that the client is trying to use. Now, clients should attempt to use those tokens in order. Next slide, please. The token expenditure reply basically contains response code, which indicates whether or not the token expenditure was successful. In case the token was was not within the window, or if it was a duplicate, the client will get an error code, and the SOX operation is going to fail. So next slide, please. Now, the proxies can shift the token window at will. Clients do not have to keep requesting new windows. Whenever a proxy deems it necessary, it can increment the Windows base by how much it wants. This can usually be done if the client has spent all of its lower order tokens, and the proxy basically shifts the window past those spent tokens and generates new spendable tokens at the end of the window. Otherwise, if the client ends up spending higher order tokens, but there are gaps, the proxy can decide to discard those gaps and shift the window past them anyway. So next slide, please. So this is what we plan to do in the next revisions of the draft. We plan to include some options that let the client request certain behavior from the proxy, like in case we're using HTTP, what path manager and what scheduler to use. We're also thinking about adding better reverse proxy support. So we would like, so as it currently stands, you can only accept one incoming connection per SOX request. We're thinking about adding some functionality wherein the client can just listen on a port and instruct the proxy to forward incoming connections to that port. Next slide, please. There's also a competing solution. It's called Zero RTT TCP converters. It's done by Olivier. There's some similarity between his proposal and mine. So they're similar in that there's all of the control data is at the beginning of the connection. Afterwards, data flows verbatim via the proxy. However, there are some important differences between our two proposals. So SOX5 is purely a layer 5 protocol. So all control data flows over TCP or over whatever reliable data stream, byte stream you want to use. It can be run over TLS. TFO is not actually required for it to work, but of course it's highly beneficial. It gives us zero RTT overhead. And as long as the middle box doesn't kill TCP, the said middle box cannot kill SOX either. And that's about it for me. I'm happy to take questions.
Thank you very much. Any questions for Vlad? Maybe a couple. Okay, great. So we're a bit late, so I'm cutting the line after those two gentlemen.
Ben Schwartz. I've been the bane of this draft.
Yeah, I know.
Thank you very much. The window system, the token window system looks a little bit over-engineered for the purpose of just rejecting duplicate TFO requests. Is it really intended for something else, like access utilization limits? Because if it's just for rejecting duplicates, then it seems like the window system is unnecessary. We could just have an incrementing identifier in a fixed size space.
Well, it's just for rejecting duplicates, either because they were sent over TFO and the client resent them, or chiefly because of replay attacks. So what else do you have in mind?
In particular, it seems like we could just essentially fix a 32-bit window and just declare the window to be the entire space, and that would be sufficient.
Well, the client is free to spend those tokens out of order. And if you make the window too big, then the server has to hold a really large bitmap in memory for each client.
Yeah, it seems to me that we can require them to be spent in order.
Well, you can't. I mean, the client can make multiple concurrent requests. So even if the client is benevolent and tries to spend them in order, they might get processed out of order.
Okay, that's very helpful. Thank you. It still seems to me in that case that it should be sufficient to associate a nonce with each essentially in process, every active command, every open socket or something like that. Or there might be some way with, anyway, I think we might be able to find another design for this, but it's helpful to understand more about why you chose this design. Thanks.
Yeah, sure. We can take it to the mailing list.
Thanks. Stuart Churcher, Apple. Can you go to the last slide in your presentation?
This was the last one presented. Do you want?
I cheated. I looked on the website.
I'm sorry?
I said I cheated. I looked on the IETF website.
Okay.
Just very quick minor point. I don't know whether this is in the draft as well, but on the last line there, you mean if x is less than or equal to y. If you think about the case where x equals y, y minus x is 0, which is certainly less than 2 billion. So you mean less than or equal?
Yes, sure.
Thank you very much.
Thank you.
Next, thanks, Vlad. Tom, are you around?
Can you hear me?
Yes. Go ahead.
Okay. Hi, my name's Tom Herbert. I'm going to give an update on identifier locator addressing. Next slide, please. So a quick introduction. I guess this is a review. I have presented this before. So ILA is an identifier locator split protocol. We anticipate use cases in data center and mobile. Some of the important properties, so this is address translation, not encapsulation. There's no processing beyond the IP header, so we don't use extension headers, for instance, or encapsulation. There is a checksum neutral mapping that will preserve the layer 4 checksum, and this can run either on end host or in network. Next slide, please.
The slide is on. It takes a couple of seconds. Your side.
So recently we updated the draft. We changed the name to reflect that we think this is more appropriate for Intarea than NVO3. So previously this had been presented in NVO3 also. Some of the changes in the latest draft, we clarified the identifier format as being optional. So in ILA, we actually had defined 4 bits of the identifier to be formatting and a checksum bit. Those are actually optional. We made that very clear that that's an optional format that can be used per site or per deployment. We added a non-local address identifier type. This is going to allow us to basically encode any sort of address into and map it into an identifier. We added description of mobility use case, and relaxed the requirement for the exact 64-64 split. So there are going to be use cases where we want the identifier and locator to maybe have different sizes than 64 bits, and I'll explain one of those use cases in a couple slides. Next slide, please.
We're a bit late, so if you don't mind speeding up.
Okay, so what more is needed? So Suresh, a couple IETFs ago, asked this with relation to ILA and a potential working group item. And we've clarified the use cases and provided reference architecture. The addressing models and privacy also we clarified. For the control plane, we're looking more that this is kind of a database more than anything. We've added running code and we have some deployment. So next slide, please. So the next slide is some use cases. So this is something we presented previously, and it illustrates the various use cases. Next slide, please. So this is a reference topology. The important thing here is that we consider this to be an ILA domain. At the border or ILA routers, they will do translations for packets coming into the domain, and those are translated and directed to ILA nodes via the underlay network, and an ILA node's reverse translation is done. Next slide, please. So when we look at the data center, very similar. There's gateway, host. Now instead of having nodes, generic nodes, those are VMs or tasks. Next slide, please. And similar in mobile network topology, very similar architecture. So we still have gateways, now we have vNode Bs. And the point of these last three slides really are to illustrate that there's a common thread here amongst the different use cases, and we believe that they will share a lot of similar code and protocol. Next slide, please. So we have three addressing modes now. Singleton addresses, this is kind of where the point we started from. This is the canonical identifier locator split, where 64 bits is used as the identifier. We have added /64-bit assignment. This is, for instance, used heavily in the mobile use case where devices are getting /64s. I haven't documented this in the draft yet, but we have a solution for this. And as I mentioned, we added the non-local address, which allows mapping arbitrary 128 bits into an identifier in order to transit a network for, say, a completely remote address. Next slide, please.
So there's three people on the line. We're cutting the line now. Thanks.
So the control plane, as I mentioned, we're really looking at this as a key value store. And as such, it's a database. And so the security, ACLs, replication, PubSub, many of the things in the database become important. And there's some various examples of how this might be implemented. Next slide, please. So running code. We continue to support the code in Linux. There were some patches recently that fixed a couple of things. We have an ILA router implementation in XDP, and we did one in DPDK, I think 3 IETFs ago at the hackathon. We will be open sourcing reference control daemons soon that, as I mentioned, implement a database sort of control plane. For real deployment, Peter can probably fill you in more on this, but Facebook is using ILA virtual addresses to replace VIP injection. And for mobility, we are currently working on a proof of concept, basically as an alternative to GTP user plane in mobile networks. Next slide. So I guess my question again is, what do we need to get a working group item? Is it appropriate in area at this point? And that's all I have.
Okay.
Thanks.
Thanks, Tom. So Suresh here. So one of the questions I asked is it one-off or not? I still don't have an answer for that, right? Like, is this a one-off document, or is there going to be like a bunch of documents to follow? So the answer to this question would be different based on the answer you give me, right? And so that was the first thing I kind of asked for, right? So is this going to be like one self-contained document and nothing more to follow, or is it going to be like 20 other documents to follow this, right? Like, and the answer to this taking up in the Intarea would be different in both the cases.
I see. So my feel right now is I'd prefer it to be one document if possible. I think it's simple enough, and since there's no actual change on the wire protocol, I think that's a benefit. The control plane is obviously the interesting question, whether or not we actually need a formal ILA-specific control plane, or if it's sufficient to say that, say for instance, we do have the database control plane, or use SDN or OpenR or something like that.
Right, like, and that requires scoping, right? So like one of the things we talked about probably a couple of meetings ago in office hours was that if you want to run this at internet scale, you need different things, right, than if you do it in a control domain. So like if you scope the document properly, I guess you can probably get away from like doing anything larger than like just the database you talked about, or they are using an SDN controller, but there's no SDN controller that works on like, different administrative domains, right, really. So that's kind of very hand wavy to say like an SDN controller would do it if like you're talking about the internet scale deployment of this. So like the thing I was suggesting was like either like, go scope it like to the things like the deployment scenarios you want to do it, or like, do the whole work, right? Like that's pretty much the options in the table there.
Right, and I think, going back to the referenced architecture, those really are scoped to be within a single domain. It is possible to use this inter-domain, but I think the initial deployments, the initial design is really going to be around bringing this up in a network more or less as a replacement for encapsulation or segment routing or equivalent to segment routing or what have you. So it really would be constrained within a domain for the most part.
Okay, perfect, thanks.
Shri Gundavelli, Cisco. So I have one question on the mapping table. So Tom, where do you keep the mapping table? Is it centralized, or do you distribute the mapping table to all the ILA routers?
That if you look at the reference, I guess you can do it offline. There's ILA routers and ILA nodes. ILA routers, the intent is it would contain the database. They might be sharded to handle the load and replicate it, but they would contain the full database. And then we would allow kind of caching nodes to contain a working set of translations, and those might be used within the network. And the routers might be used at the edge of the network where packets coming in, so the routers would have higher load. So the answer is routers would contain the whole table, and we do have other devices that can contain a cache of entries.
So since, thanks for that. So since you said it's applicable for mobile environments, I'm wondering like, if I take an operator like, Verizon or some whatever operator, 100 million subscribers, is it reasonable to expect that there's a database of 100 million entries at every router? Is that a practical?
No, it would have to be sharded. So the database, like any other large database, we can't fit the whole thing into one device. So you'd want to shard it, and the sharding would be based on the what we call the SIR address. So the SIR address would hit different routers that contain a different part of the sharded or different shard of the full database.
Okay, maybe a last point. Like, I think it's not a standalone. I think to Suresh's question, it appears like a number of extensions. It's not just a point, one simple specification, right? You need a mechanism for populating those mapping entries. You need a lot more infrastructure for this entire thing to work. At a high level, it appears like a NATed solution. It's fine. I can understand that. But you need a lot more for the entire system to work. You need the many other things in place.
Well, I agree with that, but I kind of liken it to IP and routers. So routing protocols can be developed independently of IP, which is the data plane protocol. So I guess maybe that's a poor excuse, but that's somewhat how I'm rationalizing it. Maybe that's not right.
All right, thank you.
Thanks. Lorenzo, you mind
Lorenzo,
making it fast?
Yeah, a couple of things. First of all, it does really sound a bit hand wavy to say, well, we're going to shard it. And you can shard it. You can shard the database, but if the nodes that are doing inline forwarding have to forward at line speed, and you want to have efficient port utilization on the network, you can't just shard the database arbitrarily, because you'll end up with a lot of capacity loss, I think. And so basically that goes back to Suresh's point. It seems kind of hand wavy. So you would want to have a clearer deployment statement, I think. The other question is, and I really have to ask you this question because you said it's not written down in the draft. How do you do mobility with 64s when you have 100 million 64s? Like, how do you even do that? It seems to me that there's not enough bits in the IP address to do that.
So the plan there is, and I think this also was mentioned in ILNP, basically what you do is you encode into the locator an index also. And the index refers to a locator-specific table that resolves to the prefix. So it's the locator plus some index, which is in the upper 64 bits, that actually indicates the prefix, but that has to go to the locator because the table is specific to it. So I figured you'd probably ask that question. I need to write it out, but I think it's probably a viable solution. But as you've always pointed out, we can't touch low order 64 bits in that case. It's the interface identifier, not an ILA identifier.
I think you'd get a lot better, you'd have a lot better chance of getting consensus if you explained these scenarios a little bit better.
Well, we need to, so that one is, we need to flesh out, but I think it's pretty clear that without a /64 solution, this would be hard to sell it everywhere.
Sorry, the line was cut before.
It's just a correction.
We're out of time, so take it to the list, please.
Thank you.
Thanks, Tom. Daniel?
Hi, good afternoon, Daniel King. Appreciate that effectively we've run out of time now, so I'll spend 60 seconds just highlighting a piece of work. This is architectural considerations for low latency communication across the internet. There may be a sense of deja vu. You know, this topic kind of came up about 5 years ago in ISOC with the workshop. Essentially, we're now at a point where we want to look at some of the emerging 5G use cases and applications and requirements that are coming out of various European projects and start investigating what tools, architecture, capabilities the IETF and other organizations have for solving quite a broad range of critical requirements. Now, clearly, the use cases are many. This particular document takes a number of these low latency use cases, essentially 3, and tries to expand specifically on bandwidth, endpoints, QoS, determinism capabilities, and look at sort of considerations for how these might be deployed and operated across public internet. So, of course, you could mitigate sort of latency issues with dedicated links and maybe sort of lower layer traffic engineering technologies. But, you know, as mentioned in the title, we want to see if these are actually sort of feasible across public internet. So if you could look at the draft, you know, we'd certainly like input from the working group. Of course, this topic is much broader. It spans multiple working groups, multiple protocol mechanisms, interfaces. Maybe there's some kind of template definition that's required for application to network interaction. There may be extensions required to existing QoS mechanisms. So our plan is at some point next year to have a workshop either through sort of the IETF, IRTF, or external, co-located with one of the academic events.
Thanks a lot, Daniel. Any quick question before we close down? We're really late anyway.
Quick question. Do you make a distinction between just low latency and ensuring that low latency?
Yeah, so you know, there's the guaranteed delivery of packets for application-specific environments. Remote surgery is kind of an interesting example where actually latency is actually critical or important, but actually delivery of every packet is more important. So it really depends on the specific use case.
Are you interested in latency purely from the end-to-end perspective or breaking it down into the various places like data center access?
Yeah, exactly. And so there's kind of the macro aspects of the end-to-end service, and there are mechanisms that we can use to measure latency, but it's just as important to look at the micro aspects of latency, whether it's link, segment, interface, maybe even switch fabric. And it's not just about setting up and reserving this sort of latency or latency bounds, but it's also measuring, and what tools do we have available there. Those are open issues as well.
Thanks. And your name, Paul?
Sorry, Paul Congdon, Tulak Networks.
Thanks. All right. So thank you very much. Thanks, Daniel. And that's it.